Hi, I'm Zuraf Kashu. I'll be talking about divide and conquer algorithms today, and we're going to be looking into quicksort and merge sort, and we'll be discussing about how these two algorithms work and how it is compared to the other algorithms in the place. So let's get started. We'll get started with first recursion and how recursion is used in divide and conquer algorithms. So the first thing is that the recursion is the basic of how these algorithms will work. Now you will have to understand how recursion works. Here is a short example. Int recursion x, and if x is equal to 0, then it'll return. And if the otherwise, then it will return as recursion x minus 1. So that's one thing. Now, the recursion function is being used again inside the function. That's basically the whole idea behind recursion. And you'll see in divide and conquer how we use this. Now, divide and conquer approaches work very differently as compared to the other algorithms and other approaches. Its approach is based on dividing the problem into subclasses, subgroups. Now, we'll compare them and combine them later to conquer the problems that we're facing. That's basically the zest of how we're going to deal with divide and conquer. Now let's take a look at an example right here. It is a very basic function of a factorial, and here we are doing a factorial of 6 by recursion. Now this also has some uh, features, and basically what we're going to be doing. Shit. Now, basically, the recursion here is undergoing many steps. It is dividing, it is conquering, and then it is combining. That's the main three steps on how the divide and conquer algorithms work. So first, so we look at the function, and we see that it is has a return function if n is equal to 1. That's only possible if the the algorithm or the array is sorted. Otherwise, we'll go into the else mode, else condition, which runs into recursive function, the function that is called, that is recursing. This will create division. This will create comparison. This will create conquer, and that's how you'll be conquering the question. Now, putting it back to combining, it will automatically be returning a value. For example, if we run this first time, we'll get 6 into 5 because n minus 1 is 5. Then after that, we'll get 5 into 4, and so on. The total product will get keep adding into n, and so on. We will proceed. Now let's take a talk about how merge sort will work. Now this is merge sorting. As you can see, it has time complexity of on log n and worst time complexity of on log n. So it is a pretty popular used algorithm, which is very well known as well. And as you can see in the video, you can pause the video here and you can take a look at this graph on how the problem gets split into multiple arrays. For example, that's a array of 7 elements. Now it will get split into 4 and 3. Then it will go on further splitting into 2 into 1s, and it will get sorted, and then it will get recombined. That's basically the zest of how merge sort works. Here is a video to show that might be interesting to some of y'all. You can take a look at this. That's how merge sorting works, and it's quite interesting. As you can see, the numbers might start getting arranged now. That's a good thing. Now I'll move on. I'll give the link of this video in description below. You can check that out. I'll be moving on to the other sorting algorithm, quicksort. Now, what quicksort does is that it takes a pivot and then it uses the pivot to and places the elements left or right based on how they are. If they are greater to right, if they are less, then to left, and so on. It creates a divide between its pivot. So the selection of pivot is another thing, but that's how quicksort works. So these two are basically the most famous ones amongst the sorting algorithms of divide and conquer method. Now it has best time complexity of O(n) log n and worst time complexity of O(n) square. This is something to know that it has worst time complexity of O(n) square, which is quite high. But it has other advantages as well, as it takes very less space and it is space efficient. So its space complexity is less. So it is quite preferred as well and very well low. Now I'll be comparing the this sorting algorithms with other sorting algorithms. But before that, we have the video of quicksort. That's how quick sorting takes place, and that's how it will get sorted. You can take a look at this. It's very interesting. And I'll also paste the link of this video in the link down below. You can go out and have a look at it. There's also pretty algorithm sorting videos on there. You can also check them out. I'll paste the link in the description. Moving on, comparison of other sorting algorithms with the two sorting algorithms we talked about right now, quicksort and merge sort. Merge sort will be working on, as you can see, best time, average time, worst time, and space complexity, as well as the quicksort space complexity, as I told you. Now, you can compare this with so many sorting algorithms. This graph really tells us the details about how the algorithms work. So that's the algorithm aspect of it. But there are two main other methods which are called greedy method and dynamic programming. Now, these are the competitors of divide and conquer, you can say, and two different approaches that you can take a look at and find the best one that you think would solve your problem. It has, as it says, details. You can pause the video here and take a look at this. Moving on, I'll conclude with the things that I have told you. What is the recursion? What is divide and conquer approach? How you apply it? Merge sort, quick sort, and comparing divide and conquer with other algorithms. I even have a blog written on this. You can check that out. That's linked in below, and I'll be taking your leave then. Thank you so much, and have a nice day.